Greetings, everybody. Welcome to this April edition of the Public Global R&D. My name is Ulan. I work in the runtime team at DFINITY, and today I will be your host. In agenda today, I guess the main theme will be around multi-chain and chain fusion. We have 3 presentations about it. We also have 2 presentations about AI and an update about storage layer. We are going to start with the important announcement from Jan about the upcoming new roadmap. And Jan, I'm handing over to you.
Thank you, Ulan. Very exciting to build excitement towards the new ICP roadmap. So we will announce the real roadmap on May 10, together with our 3rd anniversary. And so because you've seen many versions of the roadmap where we discussed what we were doing and what not. We had initially before we launched this metal roadmap with clear milestones, and later on we've moved more to a version where we announced different features and so on and so forth. And essentially, since the almost last 3 years, we were mostly communicating in terms of new features that we were doing. With the cons or the pros that we could really talk about the individual features. We had some of these were really excited, but also it was very tactical, and it wasn't really clear what these features do. It was more like a stream of features. And that was actually hard to communicate. It was sometimes hard to understand what these features really get to. Now we want to move towards a roadmap where we really communicate what we're doing in a clear way, so we can build up some excitement about what is coming, demonstrate some thought leadership, and also build up excitement towards milestones. So one big part of this is being able to better communicate about what we're doing. But it's also that we want to get also the R&D team, clearer goals and say, okay, so the next milestone will be Bitcoin integration or be Ethereum integration, and but then clearly define the story around that milestone. So what can you do with it, right? Do you need some DEXs for it? What kind of tokens you can do it? So group together a couple of features into one cohesive story that people can relate to, that we can get excited about, and also that we can celebrate, and that we can get the press and the crypto media interested in. So this will be a multiple parallel theme. So it won't be like one big stream of milestones, but we try to group them again according to some themes, so we can also show within these themes some milestones building up and other things, have a bit of story there as well. So each theme will have for now at least one. Some will have 2 or 3 upcoming milestones. So we do not define a roadmap from today until eternity or the next 10 years or something, but because the milestones will be for about the next year, maybe year and a half, and everything that lies further in the future will also have some representation of that on those roadmap, but there won't be milestones, and I'll show a bit of an example of that later on. So every milestone will include the features that we're doing. So so if the milestone is say Ethereum integration, features will be ERC20 or CK USDC. It will be some DEXs. It will be the EVM canisters, stuff like that. So every milestone will group of a few features, but then again also have a story why we are doing this. What can we get out of it? What are the use cases? We'll do some demo and blog posts around it again to build up the excitement around what we're doing, and so make sure the community can relate to that. So as I said, right, each theme will also have some future features, but they might not be part of the milestone. Just something we were maybe thinking about, or we also want to get people excited about, but their story is less clear. It's in the future. It might be somewhat cloudy, but still we want to show some of those things that we're thinking about. We aim to release the milestones in conjunction with some events for maximal impact, if that is possible. So that might mean maybe for some milestone we will when some things come closer to finishing, we might, like maybe drop or like scale down some things or change a bit. So it's also not that like the milestones will be cast in stone forever, but we will want to be a bit flexible with the milestones so that we can hit some event around it for maximal impact, and also again build up the excitement. Because the next slide shows a peek preview of the roadmap. Or really not. I on purpose did not want to already publish the roadmap, right? I think we would have like a much better version, a much more finished version. But I want us to build up the excitement also for the release of the roadmap itself on May 10. And so because here you just see like one milestone essentially repeated like a million times. But you will see like the milestone will have some name. It will also have like a metal name, but it will also have like a topical name. And you will see it have some features inside that milestone. And at the very right-hand side, you will see some features. Again, these are just copy-paste things. And on the very ugly graphics here, that will be in the future. So stuff that you will be thinking about. Again, it's not the last time you will hear about milestones and roadmaps and stuff like that from now on. It is really just like a sneak preview so that you know what's coming your way. And also, it's not only R&D itself, right? This has to be supported by the whole organization. We can really build a fast and marketing around that and get the ICP community, but also the crypto community at large excited of what the Internet Computer can do for everybody. Thanks a lot, and to be continued.
Yeah, looking forward to this roadmap, seeing so many boxes. I guess as a community member, I'm excited. As an engineer, I'm uncomfortably excited. Yeah, let's see. Moving on. Maybe you heard, but ICP is getting this new storage layer, and Stefan will tell us more about this.
Hello, everybody. I'm Stefan from the message writing team at DFINITY. And I'm going to talk about the new storage layer project that is now ready for rollout. So what this is it's a pretty significant redesign of how we store canister states on the disks of the node machines. And the reason why we're doing that, you've seen it on the roadmap before, like resilience and scalability of the ICP is very important, and this fits in there. In particular, it's going to improve the performance on subnets with large states. And it's going to give us the headroom to increase the storage size limits further. At the moment, it's at 700 gigabytes per subnet. But with this, we can increase it further. A bit more testing is required to see where exactly we can land. But we're going to be likely start slowly, maybe set it to 1 terabyte first and then increase it from there. I'm not going to talk at all about what we actually did on a technical level, but the core of it is that we took a performance critical part of the IC and we re-implemented it ourselves instead of relying on the operating system to do it for us efficiently. And the main benefit of that is that it gives us the opportunities to optimize it ourselves. And this is really the main reason why we did this project, because we need the flexibility to react to future workloads on the IC. I'm thinking here particularly about things like AI, which comes with all new performance challenges, and also things like Utopia, which widens the set of dApps that will be running on the IC. Next slide, please. So in terms of timeline, with the next set of replica version proposals, DFINITY will propose a separate replica version that has this feature enabled. And so this is later this week. And then the idea is that we roll it out to a couple of subnets first. And then over the next month or so, we'll gradually roll it out to all the subnets. And the increased state size limits increases will follow after that. And then once everything is rolled out, that's also when we'll start working on getting the further performance improvements based on this new storage design. Thank you.
Right, thank you, Stefan. I don't see any questions from community. Like, by the way, like if you have questions, please, I invite you to write them in the chat. So there are no questions. I guess best of luck with the rollout. I hope it goes smoothly. The next topic is AI optimization. Like maybe you have seen this demo that Dom presented last Friday about this performance improvement. And if you wonder how it works under the hood, Adam will explain.
Hi, thanks, Ulan. Yeah, so what we did here is we were able to reduce the cycle costs of all floating point operations by about 10 times, improving performance. Floating point operation is just anytime you have code that's like working with fractions and doing math with them, like this example below. We looked into this to improve running AI workloads like the image classification example in Dom's video, but it should also help any canister that's doing significant mathematical calculations with floating points, like a physics simulator or something like that, maybe. And the way we did this was we optimized a part of WASM time, which is our WebAssembly engine, which makes floating point operations deterministic. And I'll talk about that in more detail. These changes have been upstreamed to WASM time. And so then we can benefit from them. Next slide, please. Yeah, so on the left here, you can have a link to the video Dom tweeted where he shows the image classification and how we had 3 times speed up. On the right, example tweet from the community, so you can see people are pretty excited about it. Next slide. So just a quick overview about floating points. So this is an example of a 32-bit floating point. This is like a standard used across all kinds of hardware and machines.
Hola, ¿ahí me hablan? ¿No me escuchan?
Hello? Yeah.
Okay.
Okay. So basically, a floating point number, like everything on the machine, is represented by some bits. A few of these bits are used to say like what the digits are in the number, and then the exponent is a few bits which say kind of where the decimal place is. So you can have very large or very small numbers. There's also a sign bit. And when you have some invalid operations, like dividing 0 by 0, taking the square root of -1, you'll get like an undefined number, which is called not a number. And not a number values are represented by having all ones in the exponent. So there's actually multiple nans in the floating point spec because the fraction could kind of contain anything. And it's unspecified which nan you will get when you perform one of these invalid operations. So what WASM times nan canonicalization feature does is it replaces every nan value you get with a very specific canonical nan to make sure you're always getting the same result. Next slide, please. And a quick note about why we need this. Well, since we're running on a blockchain, you can imagine a bunch of nodes in a subnet, and some canister decides to do this invalid operation 0 divided by 0. The result will be nan. And if different nodes get different nans as the result, there's no way they're going to reach consensus because they're all going to disagree on what the result of this operation should be. And so that's why we need this WASM time pass to canonicalize all the nans to say, whenever you get a nan, it's the same one, and the nodes can agree and the subnet can make progress. Next slide, please. So I'm not going to go into the details too much, but this is the assembly that WASM time used to generate for nan canonicalization. So in the example here, we're just doing an addition of 2 floating point numbers. And basically in the second line, what it does is it compares a float with itself. One interesting thing about just from the spec is that a nan, when you compare it to itself or any other number, it's never going to be equal to any other number, even if it's the same nan. So you can always tell you have a nan if you can compare it with itself, and you get not equal as the result. So basically what we're doing here is every time we do an addition or something, we compare the result with itself, and then these jumps are deciding whether we keep our original value if it was a good value, or we replace it with the canonical nan if it was a bad value. And yeah, I mean, the details aren't so important. The main thing is just that this involves 2 jumps. And that's going to happen every time you add 2 floating points, multiply them. Like anytime you do anything with floating points, you're going to have these 2 jumps in your code. And in the worst case, these can take a very long time. If the jumps are not well predicted by the hardware, then this can be a very expensive operation, which is why we had to charge so much for them originally in the replica. So next slide, please. And so this here is the new implementation. What we modified wasm time to instead produce this code for the same example, an addition. And it's similar logic, like we do the addition and then we check if the result, in this case, we don't specifically look for unequal, we look if the result is unordered with respect to itself, which is similar to being unequal. So that identifies whether you have a NAND or not. And then this last operation, this VP blend, this is like a conditional move. Basically, we replace our result with either the original result or the canonical NAND, depending on whether our result was unordered with respect to itself or not. So it has the same result, but it doesn't involve a jump. You always execute this blend conditional move operation, which can be expensive, but in the worst case is much better than jumps that are mispredicted. So yeah, next slide. So in the worst case scenarios, like I said, we have over 10x improvement, which means we can reduce the cycles costs by 10 times, which means in an example like this image classification we had in the Dom's AI demo, that ended up in like a 3% improvement in the actual like wall clock time, end-to-end doing an inference, and lots of other AI workloads should have similar improvements. So this is all coming to mainnet soon. Like I said, the changes to wasm time have been merged in there, so it's just a question of waiting them for them to make a release and for us to use it and all that. And yeah, so thanks to the whole runtime team for helping out with this, like investigating the issue and benchmarking things. Yeah, that's all.
Thank you, Adam. I don't see any questions in the chat, and yeah, congratulations on like doing this improvement and also upstreaming it. I think that's a great achievement. All right, now we are moving to the central part of today's agenda, and that is multi-chain updates. We will start with Ashlyn, who will give an overview of the multi-chain on ICP and maybe explain us how to think about it. Ashlyn, handing over to you.
Thanks very much. And yeah, thanks for the introduction. As you see, I used multi-chain instead of chain fusion on which was on the agenda. So I want to take 1 minute of the time to take a step back in time and show you a bit of the history of where we've come from. And so I think you know with the internet computer what the goal is, so I don't need to remind you of that. But I think if we scope this conversation down to kind of the Web3 level, never mind the internet computer or the world computer, but let's just talk about the Web3 computer for a minute. What should we want to achieve with this? And I think this is all the history that you know, but I recap it briefly. So with step 1, you want to talk to the original OG blockchain that everybody knows and loves, which is Bitcoin. Okay, this is not the way everybody else in the industry did it. They kind of talked to other chains first, but we did the Bitcoin integration first. And this involved building network adapters to provide the UTXO set and implementing threshold ECDSA to sign transactions on the Bitcoin blockchain. Step 2 then is like, okay, now that you can read and write with Bitcoin, the next thing is to make this Bitcoin a bit more practical. So we wrote some canisters that would produce one-to-one backed Bitcoin twins called CKBTC, which could be used in the ICP ecosystem. Beyond this, then we did the Ethereum integration, where we could reuse the threshold ECDSA implementation that we had from the Bitcoin integration, and coupling this with an EVM RPC canister, we can get the state from Ethereum, and this can help to write to Ethereum as well. Then step 4 is to make Ethereum more practical. So similar to Bitcoin, we want Ethereum to leverage the special features of the ICP ecosystem, fast finality, low fees, etc. And we did this with CKETH. Then we want practical ERC20 tokens. And so you might think about, okay, maybe we'll end up with CK ERC20 tokens. And actually, maybe you see a demo about that later. then step okay, now we're getting a bit into it. What about BRC20 tokens? What about runes? What about ordinals? What about all this stuff on Bitcoin? Okay, fine. We do threshold Schnorr. We give you this step whatever plus. What about Solana now and Cardano and Polkadot? And okay, fine, we do more RPC. Okay, and like you see, I mean, it gets a bit crazy. And like if you try to explain to anybody what is Web3 computation in ICP, you go to the next slide and you say like, okay, the ICP web stack is maturing. Let me take it out to the public now and try to onboard developers to actually use these fancy features that we've been building. And then you go to the next slide and you see, okay, I mean, this is pretty much a standard conversation that we have with developers. Oh, yes, it's entirely possible to build true Web3 on ICP, like a one smart contract here. You can leverage the Bitcoin network adapter running on ICP nodes alongside our replicas, which give you direct access to the UTXO set, which is great because then you can use chain key signatures to derive Bitcoin addresses. And then you can use threshold ECDSA to sign transactions. And then with the network, you send them here and you send them there. And at some point, people kind of look at you and go, who is this crazy lady trying to tell me like how to build smart contracts? Or well, maybe I just go there and like use the smart contracts that are already on the internet. And I don't even have to learn anything. I just copy and paste and press a button. Why is she trying to get me to actually understand things? And so I think sometimes people get a bit overwhelmed when we try to tell them how things work in the ICP ecosystem. And I think maybe this is a bit of hangover from the fact that it is such a like R&D focused organization. And so over the last while, it's been a bit tricky to actually talk to developers because now, as you saw on the previous slide, like the list of things that we could offer is growing and it becomes more complex. And so the goal is to a bit maybe abstract it so that you can kind of stand back from like the details and actually engage in a conversation and bring them in gently and then kind of expose them to the crazy stuff that happens under the hood if they stick around long enough. So if we go to the next slide, we kind of move on from the multi-chain idea where we didn't really have the terminology to explain this stuff, and where people like me were scaring away developers by like going all in on the details from the start. But generally, we want to position ICP's Web3 capabilities more for developers and end users rather than explaining the details that people like the engineers at DFINITY or at other L1s will be clever enough to know about. So if we go to the next slide, we see kind of a nicer, higher level picture of what Chain Fusion is. And so I think this is kind of an easier entry to the conversation. You say, you want to do true Web3? Okay, power your app with Chain Fusion. What is Chain Fusion? Well, it depends. Are you a developer or are you an end user? If you're a developer, let's talk about Chain Fusion technologies. They contain things like chain key signatures and network integrations. Are you scared yet? No? Okay, then maybe I can go into it a bit. And you see that, yeah, there are a bunch of different signature schemes that we've implemented, or there are a bunch of different ways to do network integrations. And this just kind of helps categorize things. And if you're an end user or a developer also, and you're more interested in the application side, you can say, we have these CK tokens that leverage Chain Fusion technologies that we can use in the ICP ecosystem, or else bridge ICP tokens over to other ecosystems. And then there are ecosystem apps like Oisy, for example. Bionic is an ordinals marketplace. Omnity is an interoperability protocol using the ICP stack to kind of do routing around Web3 generally. And Chain Key Exchange is a DeFi protocol, cross-chain DeFi protocol. These are just a few examples of ecosystem projects, and you'll see you'll see a demo of the CK tokens. You'll see a demo of the multi-chain voting. So we should probably rename that now to Chain Fusion voting or something like this. But this is just to kind of separate the ideas, because I saw some chat on Twitter as well where people were saying things like, yeah, CK BTC is ICP's way of talking to Bitcoin. And it's like, no, it's not. Like, it's absolutely not. So I think there's some confusion when we explain things in too much detail and with too many technical things. I think people just get confused. So this is a way to kind of separate it out a bit. And so over the next while, I think Jan alluded earlier with the roadmap, you'll learn about the next milestones for this. And I think you already gave some hints, but yeah, May 10th, you'll see there. So if you go to the next slide, we've already started a lot of stuff, and this is just like an overwhelming slide of pictures, but we've updated the developer documentation to include a chain fusion section. This was a lot of work from the engineering team and the docs team. Thanks very much. The website was updated. We've already had a bunch of events around Ethereum and Bitcoin narratives. We've had, like we talked about, Threshold Schnorr in the press a lot. We had some online events around Bitcoin as well. There's an NFT ordinals collection launched with these motokos up here. And as you'll see, there's CK USDC also being rolled out in testnet now for testing. So this is a few things that have happened so far. But coming up next, on the next slide, we see there's plenty more to come. So everything is yet to come, basically. And this is a huge coordinated effort across all the teams at DFINITY and across the hubs who are getting more and more involved in this, and with the ecosystem at large. So from R&D, you see all the R&D improvements, so threshold ECDSA improvements, threshold Schnorr integration, which will allow stuff on Bitcoin, more CK tokens, more RPC connectivity, the developer experience team for the documentation, SDK updates, demos, growth, doing developer onboarding, grants, bounties, sample code, hackathons. And so we really want to, push like a lot of the ideas that we'd love to see, getting people really, really building them. The marketing are doing a lot of the overall messaging, targeted media, press, socials, blogs, videos, partnerships, I mean, everything. Maybe the events is something interesting to note. It's probably the one thing that's not so public so far. We'll be at Bitcoin Asia, showcasing Chain Fusion. ETHCC is the next big ETH event. So if you were maybe thinking about looking for some alpha about milestone launches about Ethereum, maybe you'll see something there. The same for Bitcoin Nashville, Jan, don't kill me. And then Singapore Blockchain Month will have a big bang as well. Overall, huge effort from everybody, and everybody's kind of coming together to support this kind of clear narrative. So yeah, happy to hear feedback, happy to have you join us on this Chain Fusion journey. And just a small tiny update, Kyle Langham usually runs the Multichain space on X on Mondays. He had Multichain Mondays. It'll now turn to a Chain Fusion live space, so you can keep up to date with everything that's going on with him there. Thanks very much.
Thanks a lot. Yeah, I really liked your Chain Fusion tree. Like, it looks like the tree reduces confusion about Chain Fusion. Yeah. There is some discussion about the terms. Maybe Ashton, you could take it on chat because we are a bit over time. Let's move on to demos, and this is the demo I was looking forward to, and this is about the CK ERC20 tokens on ICP. Gregory, are you here?
Yes, I'm there, Ulan. So hi everyone, I'm Gregory from the cross-chain team, and today I would like to present you the latest development in the integration of CK ERC20. So what is CK ERC20? Well, it's a family of tokens which are native to the IC and which are backed one-to-one with the ERC20 tokens on Ethereum. So for example, one CK USDC on the IC would be fully redeemable against one USDC on Ethereum, and similarly for USDT or other tokens. So to recap, what is ERC20? Well, it's a fungible token standard on Ethereum, and basically any Ethereum smart contract that satisfies the interface specified in the standard is an ERC20 token. And there are like hundreds of those tokens, capitalizing a bit less than 400 billions of US dollar. The two most important being USDT and USDC. So why do we want to do that? Well, this would allow for cheap and fast transfer tokens on the IC. And also because some of those tokens are stable coins like USDC or USDT, by bridging them to the IC, we automatically brings stable coins to the IC. And also overall, we would like to hope to attract some of that liquidity I mentioned before and some of the developers of that ecosystem to the IC. So how do we plan on doing that? Well, we already know how to bridge ETH to the IC, that's CKETH. So we're going to reuse that. And for the MVP, we're going to focus on one particular ERC20 token, which is USDC. Below, there is a link to the forum. If you have any question or any feedback, please feel free to reach out. We would gladly hear from you. So without further ado, let's proceed to a deposit, meaning a user on Ethereum has some USDC and would like to bridge them to the IC. How would that work? So on the left-hand side, we have the IC with the CKETH minter. That's exactly the same canister as in the case of CKETH. And we have on the left the CK USDC ledger. So that's a ledger dedicated to CK USDC. In particular, it's not the same ledger as the CKETH ledger. And on the right, we have the Ethereum network, where we're going to focus on two smart contracts. One would be the USDC smart contract, which is in that case managed by Circle. And the other one would be a Little Helper smart contract. And the goal of that Little Helper smart contract is to bind an Ethereum transaction to an IC principal. So basically, those ERC20 smart contracts, there could be many of them, depending on how many tokens we want to support. But this Little Helper smart contract on the right is going to be the same for all ERC20 tokens that we will support. And then how a deposit looks like. So let's say the user already has some USDC. So the first step would be to call the USDC smart contract. And because it's an ERC20 smart contract, it has an approve method where the user can specify another Ethereum address. In that case, that would be the Little Helper smart contract and some amount. And that would mean that the user allows the Helper smart contract to use some of his funds. That's very similar to an RCRC2 approval. And the second step would be to call the deposit method on the Helper smart contract. And because that smart contract is the same for all ERC20 token, the user will specify which type of token he wants to deposit. So in that case, USDC, the amount, let's say, for example, 2 USDC. And because USDC uses 6 decimals, so that would be represented as 2 million. And also the IC principal for which the future CK token should be minted to. So now, since it's going to take some time, I will jump ahead and start doing the Ethereum transactions. So here on my screen, you should see like the Minter dashboard, which is very similar to, for example, the CKBTC dashboard. And so it represents all state modification that occur on the Minter, for example, all deposit and also all withdrawals. So this particular one tracks, like in production, the finalized block height, which on Ethereum occurs every 12 minutes. So that will be a bit too slow for the demo. So I'm going to cheat a bit and use exactly, let's say, the same setup, also deployed on mainnet, but this one tracks the latest block height. And so this should be actualized like every 12 seconds. So now I could jump ahead and start calling the various smart contract I need to via EstaScan and so on. But we have something more fancy, which is OISI. And there we can use the bleeding edge, so the latest version of the testing version of OISI. So let's be bold. So OISI is basically a decentralized wallet that's directly accessible from your web browser. Doesn't need any plugin, and you are ensured that the private key cannot be reconstructed by any single entity. It's like threshold share among the IC nodes. So let me authenticate. Right, so the front end is communicating with the backend, and basically the backend via threshold ECDSA has a dedicated public key pair for me, for my user, corresponding also to an Ethereum address. And so, for example, on that Ethereum address, I already have some USDC. So currently I have 6 USDC. This I could, for example, check directly on the smart contract. right? So here I have my Ethereum address, for example. I can interact with that smart contract in various ways, for example, via Etherscan, and I can check the balance there, and I can see, okay, this corresponds to 6.2 US dollars. And now that I have some USDC on Ethereum, well, I want to bridge them to DIC. So let's say I want to bridge one USDC to CK USDC on DIC. And if everything goes well, basically Ozzy is going to take care of everything for me. So he's going to contact the USDC smart contract to do an approval. He's going to contact the helper smart contract to do a deposit, and then refresh things. And after a while, this should be picked up by the minter. So while we wait for it to be picked up by the minter, we could go back a bit to the explanation. So now basically the user called the deposit method, and the helper smart contract is going to do two things. So first is going to call the USDC smart contract, is going to call the method transfer from. And we know this method exists because this is part of the ERC20 specification. And by calling this method, it's going to move the user's funds to the minter's address. And the second thing is going to emit an event which specifies which token was deposited, by which amount, and to which IC principal. And so this minter's address is exactly the same address as in the case of CKIF. It's derived from the threshold ECDSA public key controlled by the minter. So only the minter can, via threshold ECDSA, sign transaction to move funds from that address. And afterwards, we are exactly in the same situation as for CKIF. So the minter is going to retrieve those logs by using the standardized JSON RPC API, and by retrieving those logs from some various providers. And so now, like for CKIF, because based on that information, we're going to mint, and we want to maintain the strong environment that one CK USDC token is fully backed by one USDC token. So we're going to create multiple such providers and only mint if all those results are equal. So now let's go back to Ozzy and check that if everything is there. So now I should be able to see that I received one token. I can also check what happened on the address directly. So this would be the address, which is controlled by Ozzy. And if I do a refresh, yeah, I could see that 1 minute, or I mean, almost 2 minutes ago, two transactions occurred. One is an approve, which was made to the USDC smart contract. And the other one is a deposit, which was made to the helper smart contract. So now that I have some token to play with, I can do a withdrawal. So meaning I have some CK USDC token on the IC, and I want to get back USDC on Ethereum. So here we need to consider a third canister, which is the CKETH ledger. And that's because on Ethereum, if you want to do an ERC20 transaction, this will involve transaction fees, and those fees need to be paid in ETH. So for that, we're going to use some of the user's CKETH to pay for those transaction fees. So basically, the user needs to do three things. First is to contact the CKETH ledger to approve the minter to spend some of his CKETH to pay for transaction fees. Then to contact the CK USDC ledger to approve the minter to use some of his USDC, let's say 2 USDC in that example. And third, to contact the minter to effectively start the withdrawal to some given Ethereum address. So now I could do that via DFX, but it's much nicer to do it via Ozzy. So here I can click, okay, let's convert it back to my Ethereum address owned by my Ozzy wallet. And this should take care again of everything. So it's going to contact the CK USDC ledger to do an approval, going to contact the CKETH ledger to do an approval, and finally contact the minter to start the withdrawal. Right, so if I go now, for example, to the Minter dashboard, I should see that there's some withdrawal request pending, yes, which is this one. And so while this is being processed, we can continue the explanation a bit. So what happened afterwards is that the Minter keeps track of a fresh estimate of transaction fees on Ethereum by contacting the various JSON RPC provider, and then it's going to estimate the transaction fees and burn that amount of CKETH on the ledger, and then burn the 2 USDC on the CKUSDC ledger. Afterwards, the transaction is going to be enqueued and processed on a timer. So then the Minter is going to create an Ethereum transaction calling the USDC smart contract and calling in particular an ERC20 method called transfer, which is going to move the funds from the Minter's address to the specified address. And afterwards, like in CKETH, it's going to be signed via threshold ECDSA, sent over the network via the various JSON RPC provider, and then we're going to wait for the transaction to be finalized. So if we go back now, maybe the transaction was already sent, yes. So we should be able to see it also on Etherscan. Right, so we can see on Etherscan that basically everything looks like this is a standard transaction, standard Ethereum transaction sent from some address corresponding here to the Minter's address to my OZ Ethereum address. So things are completely transparent to the Ethereum stack. Yes. And all of this is really possible thanks to the threshold ECDSA integration. Right, so to conclude, CK Sepolia USDC is already live. Please go ahead and try it, play with it, try to break it. We would welcome any feedback. If you have any question, please reach out to us to the forum. CK USDC is to be released soon, probably in one of those named milestones. As you have seen, OZ integration is really around the corner. And one thing I didn't mention, probably a topic for next Global R&D, is that we set up an architecture that's scalable with a number of ERC20 tokens that we want to support, such that basically adding a new ERC20 token requires just a single NNS proposal. So that means you can expect more ERC20 to come. So special thanks to all the past and current members of CrushChain team, also Thomas Miller from ProdSec for the speedy security review, and David for pushing the integration of OZ for the global R&D. Thank you very much. And back to you, Ulan.
Thank you. Great work and great explanation. There is some discussion going on chat. Maybe you can take a look. And okay, one more demo on Multichain. Bjorn, handing over to you.
Yeah, thank you, Ulan. This is Bjorn from the research team, and I want to talk about multi-chain voting or chain fusion voting. And the background of this is when we thought about how can we bring together two big narratives on ICP. Like on the one hand, chain fusion technology, we heard about it earlier, like all the great stuff about integrating with other blockchains. On the other hand, on-chain governance. I mean, ICP is governed by an on-chain DAO. We have a great DAO framework, the SNS framework on ICP, and to bring this together. And it turns out like in the intersection, there's actually a nice use case, on-chain voting, leveraging Ethereum and ICP. And the idea is that right now on Ethereum, you have quite a few DAOs, for example, that do the voting off-chain, for example, using Snapshot because of high gas fees. And then somebody has to bring back the result on-chain, which of course can cause friction. And so hence the idea to really do that seamlessly, do the full voting process on ICP, but using Ethereum and token balances on Ethereum to determine stuff like voting power. This is joint work with Severin from the SDK team, and there also were great inputs from Dominic from the growth team. Next slide, please. Yeah, so here how that's done, high-level architecture. So like there are two canisters for the voting, a front-end and back-end canister. They talk to the Civic canister, and that's used for the MetaMask login. So like that's a community project written by Christopher Lund. And it allows you to log in using MetaMask and then link an ICP principal with an Ethereum address. And in addition, the voting backend talks to Ethereum using the EVM RPC canister, which in turn talks to various Ethereum JSON RPC providers. That's like the login screen. So I log in with my MetaMask, leveraging the Civi project I mentioned earlier. And then I get to this sort of a submission screen where I can, for example, actually maybe I can quickly say, you see here on the top right, you see like my ICP principal and the linked Ethereum address that belongs to it. Now, under that identity, so to speak, I can submit a proposal. Let's do maybe something like this. I can submit a proposal here. I mean, for the time being, that can be a motion proposal, but of course you can think about other types as well in the future. For demonstration purposes, I will make it a very short-lived proposal, which just has a duration of 1 minute. And now if I submit the proposal here, hitting this button, then you see we have chain fusion in progress. That's the moment now where the app talks to Ethereum and checks for the current block height. That's important because that block height is going to be used later on to determine token balances so that nobody can vote twice with the same token. And you see now under open proposal, like we have like this proposal now popping up with me as the submitter. You see it's like only 1 minute open, so I rather hurry now and do the voting. Now again, the app is talking to Ethereum, chain fusion in progress. This time is fetching the voting power for my Ethereum address at the block height that was linked to the proposal. And now you see we have vote 1.2 ETH. Ethopolia in this case voted yes. You can also see, like if I check in my MetaMask, it's corresponds to my current balance that I have under that address. And now, so the proposal is doing well. I mean, of course, now you could think about adding additional functionality here. While I mean, for example, like the question is now what happens when the proposal is actually past its expiration time, and we'll see that in a minute, because then it will trigger further actions on chain. There's an under timer in the background that checks for open proposals and closes and executes them. So in this case here, we chose that the result of this motion proposal is actually written back to Ethereum. You could, of course, also think about other actions taking place, for example, token transfers, or maybe even more fancy things like upgrading software. So anything like a smart contract can trigger could be here the result of a vote on chain, which is like the big benefit here of this sort of seamless integration. So now we should sort of pick it up. Now I refresh the proposals. You see now like the proposal is here under the closed proposals, and you see also here there is an execution hash that was now linked to the execution of the proposal. And if I click on that one, I can check in Ethereum. Actually, it's I think I have to. It's still ongoing. I can check for the details. Yeah, so I see here. If I go to the details section, I can see that the backend canister wrote for proposal 2 100% yes vote because I was the only person voting. Yes, so I think that's pretty much it. Like the project is open source. You can find it on GitHub here. Please have a look and check it out, and maybe use it for your DAO or other use cases. Please check it out. On the left-hand side, you find a link to the app that I just showed you. It should work on mobile too. So please have a go and vote. On the right-hand side, you find the link to the GitHub project, and happy for you to play around with it.
Hi everyone, my name is Arun. I'm from Team ELNA. I'm going to be real quick. I know it's already late. So what's ELNA? ELNA is a community-driven, decentralized AI agent creation platform that bridges the gap between development, creation, and monetization of AI agents in blockchain. In this presentation, I will start with why do we need AI on blockchain? And then I have a short demo of ELNA, how ELNA works, and why we built on IC. So without wasting a second, let's start. Now, any program is a set of instruction and memory. And when these programs has an output which has huge impact in our daily life, we have the priority for transparency as well as privacy. When it comes to AI, especially AI agents are most like the evolution of LLMs like ChatGPT. We know that we are familiar with the potential of large language models, and these LLMs are like average human beings. They work autonomously, and when their output has this huge impact, we need the importance of being it completely decentralized. We have seen what happened to ChatGPT, OpenAI team, and how the governance works on. And we are being from the closed source, and there are a lot of things. I'm not going into deep, but that gives us the importance of getting these large language models or LLM agents or AI, which is transparent, as well as governance, which is completely given to the community. And what we are building is a platform that basically consists of this LLM agent creation, development ecosystem, as well as monetization. And to start off with, what is an LLM agent? LLM agent is a combination of intelligence, knowledge, and interaction. So intelligence basically comes with large language models, and knowledge, maybe the large language model which is trained on one particular set of data may not be having the information about, maybe I'm creating a personal agent. It doesn't have my personal information. So we give the knowledge in the form of vector database. And that's not just enough. So to act as a autonomous agent, this need to interact with the applications. So that third side is interaction. This interaction can be like integration with Twitter, or maybe integration with your company database. So this combination of intelligence, knowledge, and interactions create an AI agent. And to be quick, so in our platform, we have the AI agent creation platform, and there's a marketplace where these AI agents can be monetized, and the ecosystem for developers to bring their let it be inference engine, vector database, or custom integrations. We are making it possible for developers to list it on our platform. So it's a new paradigm. So a lot of things have to be built from the scratch. We need to reinvent the wheel. So we are creating this ecosystem where these developers, this is a combination of multiple paradigms. Developers have their own capabilities. Some maybe developer has developed its own large language models, but for a user, he may not be able to access it through blockchain, or he may have difficulty without having a user interface. So we bridge this gap. So the developer could directly list or directly help. We will help the developer to directly get it on blockchain, and we help the user the end-to-end solution to deploy it for his own solution. Now, ELNA, through SNS, we are a DAO, and everything is public, and we are open source, and the decisions are made completely through proposals. Some of our use cases which we have done, the first solution is the support agent, which we have created for Sonic Text. And the second is AI agent, finance agent. So this is more like a personalized finance manager. And we have also integrated, worked with a robotic company where this robotic company, the robot name of the robot is called Saya. This is directly connected to one of our LLM agents. So how the robot speaks, the character, everything can be set or designed from our ELNA creator page. And the main question, why ICP? So we have been working on this project for the past 1.5 years. I have an experience in a development for the past 10 plus years. What's the difference between an A instruction and normal instruction, a normal set of programs, is that we need huge amount of instructions to be executed because the program is developing by itself. So the execution is number of instructions is very important, as well as the size. So these are the main important. I'll explain more about this in the coming slides, but these are one of the most important factors why we choose ICP. And from the story, why it is possible right now, because starting from minting simple coins from like BTC to writing instructions, writing contracts in Ethereum, now we are capable of running WebAssembly instructions in blockchain. And in other chains, only if you, even though fewer number of instructions can be executed, what makes the difference is ICP. ICP is more like, as we know, like is the AWS of blockchain, where larger number of instructions can be executed, and that's actually made it possible to bring AI to blockchain. And yeah, I will explain this more in the coming slides. So in ELNA, what we are doing is like we started off with the user data instruction, user management in the blockchain, and we started off like a hybrid model. So some things we need to reinvent the wheel, like the basic inference engine and everything have to be built. So we make it possible, like for example, off the chain models can be used. So many of your data, except more specifically the user data, vector database, and other execution and orchestration completely happens on the chain. And I have a next slide which explain more in more detail, but we made it in a hybrid approach where most of the user data interaction happens on the chain, and we also make it possible for that users could use off the chain models as well as inference engines. So and also on the client side, we process this information. This it's a combination of on the chain, hybrid, as well as client-side processing. And now the question which I was talking about, the speed and scalability, one of the important factor in ICP, whether it be Cardano, we are familiar with how Solana works, and the execution speed is very important, especially when it comes to AI interactions. It already normal interactions takes a huge amount of time in other chains, and AI is something which need a huge amount of instructions which to be executed. Now, currently, the WASM32 support a huge larger amount of instructions, and IC is ready to upgrade to WASM64. That creates a huge opportunity for developers, not just AI and other development also. This is a huge important factor. And coming to memory, we have a 400 GB stable memory, and that makes the huge difference. So these are the two important factors why we initially choose ICP. And the coming GPU canisters are very promising for us to move further with AI development in ICP. So as time is limited, I'm just moving faster. So in our development architecture, all the documents are available in docs.elna, as well as we do have YouTube videos. You can get it more details in the same. So we do have a multiple canister architecture where we have the user management in agent management canister, where we list the user data, the developer informations. If anybody's listing their own inference engine, they can host it in their own canisters, and they will be having a listing canister where we manage the listing of multiple other tools, and we do have our own tools like vector database, inference engine, all the tools comes under the developer ecosystem. And when it comes to data, we have the user data, which is in the form of vector database, which is stored in the user side. So the management of this particular vector database relates with the user, and he can have the complete access, like who is accessing the information, and he have the complete ownership and authority of his own data. And we have canisters for the retrieval augmented generation, the prompt engine, the logging canister, which the log canister actually shows the authenticity of how the data is being generated, and the developer management canister that includes as I said before, that we have the listing of multiple tools. So how it is being used, and when it comes to monetization also, the billing part, everything happens through developer management canister. So we have this multiple canister architecture where the inter-canister communication happens through the execution of the run. Now let's have a quick demo.
Welcome to the demo video of AI agent creation on the ELNA platform. For an imaginary actor, Alexander Sterling, we are creating a social media manager, or rather a digital twin. For the knowledge base, we have created a
we're trying to create an AI agent with information like that includes the prompt, what it has to do. So this is more like a personal social media manager for an imaginary person. So, and we are integrating this to his Twitter account. So initially, we got login with a wallet, and we click on create an agent, and we give a name to the agent.
Description means the description of the agent.
Here we give the prompt and how the instructions have to be executed. So here
we've already prepared the biography as well as the description
and the instructions and what have to be displayed in the
step-by-step prompt on how
AI listing page. This has to be given here in the agent creation part. So here, I'm just fast forwarding it.
Avatars to be shown.
So here you can see the description is which you see in the marketplace, and greeting is the initial greeting, as it says, and the biography is the basic prompt which give to the AI agent.
The marketplace. Once I click the next button,
when you click
I'll
next,
get a screen to upload.
here you can
knowledge
upload the
base.
file, and these files will be converted to
Here
vector
I can upload
database
the
and
PDF
be used
I
for the
showed you
retrieval
before,
augmented
which
generation.
is the knowledge base that includes all the information about his personal life and profile. So I'm uploading this document. Once I click OK, this will be connected to vector embedding and hence to our vector database. Now here I have the provision to integrate the agent to multiple external services that include X, WhatsApp, and also this can be used to integrate to other automation.
Now we are connecting to Twitter. As I said before, the third part of AI agents in ELNA is like integration to external services.
To X.
No.
Here
we are connecting to Twitter.
Developer account. Unique.
So create a Twitter API key for connection and the basic information that includes the API keys, the bearer token, the consumer key, and I'm just fast forwarding these things.
Access token.
Here, it's connected to Twitter.
In this case, the actor.
So basically communication happens through the Twitter. In
Let
some
me
of the cases, we have to use the
prompt
HTTP out call for the communication, and for other cases, it happens completely through the canisters.
And ask him a question. Something
here what
related
happens
to
is that
what we've already said in the
have created
base.
a virtual agent
Say just,
to act
watch
behalf
this
of this
latest
particular
film.
user, this imaginary user who is an actor.
How do you prepare
And
for such
from his
intense role?
uploaded information and the
Keep in mind,
instructions which is given
knowledge-based
as the form of
document
prompt,
we had uploaded contains all
when
information
I
on his approach to acting, how he prepares for
tag
roles,
or when I
and other
tag this
personal
particular person,
details.
our AI agent automatically replies to this
Activity
particular actor.
collects,
So this is
and
the
that
overall
tag will be used by our API to connect to
implementation
X.
on how
And this will
an
be
example on
sent
how
to
an
a
AI agent can.
engine for analysis. In the prompt engine, the knowledge base is used to generate the given. And if the API, you should be getting a reply right around now.
As you can see, there's a notification.
And
Yeah.
we've got the immediate reply from the agent
This reply is actually done by the agent.
on behalf of the human.
So this is one of the few examples which we have done with AI agents on ELNA. And this can extend up to starting from support agents to autonomous humanoid robot integrations. The applications are vast, and we have a total addressable market which includes AI applications that need a strong requirement for data security compliances, the generation who take the responsibility of this generation. And these are the type of application, more specific application we will be concentrating into. And the serviceable addressable market are the ones like there are other chains or other projects which like Fetch AI or different projects which say they're completely on chain, but most of the parts are not working on chain. They do have a verification part on chain. But the beauty of ICP is that everything can be run completely on chain from the front end, from the inference engine to the end user integration. So that makes we are looking for applications which require these kind of authenticity and privacy and authority, which requires this validation. And to close off with how we started, like we on the Q1 of 2023, we have this hypothesis like, is it possible to actually do something related to AI on blockchain? And that's how I started the working on a POC, which is running a smaller model on ICP. And we have the POC on the Q1 part, and later we have worked for the grant and have posted. Everything started with a post on DFINITY Forum. And the first forum has a huge responses from the community, and that I have resigned from my job, and that's how it started. And we have applied for the grant, and the initial deployment of agent was done for the last Q4. We have Pleasant for IBW. We have worked with Sonic for creating an AI agent for their own platform. And to make it short, and we have done our SNS last month, and we are now in the plan of listing it on CoinMarketCap and different other platforms. And we are now working on the AI agent marketplace more specifically. That includes monetization of agents, integration of integrating developers to the platform, making it onboarding developers to the platform. We are also having a hackathon next month. That will be the Asia's first of its kind decentralized AI hackathon. And likewise, we are trying to onboard developers to a platform for listing their own inference engine, vector database, and a lot of applications. That's our future scope. And coming to our tokenomics, make it quick. We have a dual token economics, very similar to ICP, where the ELNA tokens, which is the SNS token, stays as the governance token. And along with that, we are trying to create a secondary token, which could be used for the monetization and in-app purchases and everything. Now this is the team. That's all. I try to make it as soon as possible. I know it's already late. I'm open for questions. Thank you.
Thank you, Aaron. I don't think we have time for questions since we are way over time right now. But how would people, what would be the way to connect or ask questions, like maybe offline for you?
Yeah, we are available on Discord. We are available on Twitter. And with me here, head of communication, Hene is also available on the call. So anybody who would like, you can scan this code. Anybody who would like to connect us, we can connect us through Twitter and Discord.
All right. Thanks a lot.
So I think that will be the code on the first slide. So yeah, Discord and X, yeah.
Yep. Thank you. All right. With that, we're wrapping up.
Yeah.
Thank you everyone for joining, and sorry for these technical issues. Okay. See you next time. Bye.